everyone, welcome to my talk, Signal versus Noise. And I wanted to have a conversation about creating effective automated test suites. So when I was thinking about what I could talk about during XT Summit, I was really struck by when we build the modern web, we kind of think about, we spend a lot of time building things really fast. We're trying to deliver to a client as soon as possible, and that's really good and all, but it turns out we also break things faster than we've ever done before. When you write a lot of code, it turns out that you sort of look like this guy sometimes if you're breaking a lot of things unintentionally. It's not a very good experience for us as engineers, right? We're really stressed out, and we spend a lot of time solving some problems that maybe we didn't really intend to solve in the first place. The good news is that being an engineer, right, we work with a lot of really smart people across the entire industry. And those really smart people have provided for us a way to sort of save ourselves from ourselves. We're able to write an automated test suite to kind of help us avoid problems down the road and know that we're delivering the code that we intend to deliver. An automated test suite has kind of become the holy grail for rigorous engineering programs. Any company that talks about how great their engineering team is talks about how they use things like test-driven development or, frankly, just automated testing in general. It turns out, though, that even if we have the holy grail, we're really good at kind of doing it poorly. When I was talking to some people about this talk and some of the content I wanted to put into it, I was reminded of a colleague from the days of Sapient Yore that was on a very big project for a client. And he was looking through the code base, and he noticed that a bunch of their tests were commented out. And he thought that was kind of strange. So he asked why. And it turns out that the reason why was because the tests were failing. So that's not very good. More recently, I was talking to a friend that works outside the organization. He works for a financial services company that shall remain nameless for the purposes of this conversation. And he was having a really tough day, and I was asking him what was going on. And it turns out that his team had pushed new code to their public-facing website. And it turned out that it had a bunch of unintended consequences. And as they tried to sort it out, it actually resulted in a multi-hour downtime for their public-facing website. When it was all said and done, I asked him a few questions, like, do you guys have an automated test suite that could have prevented this? And he said, of course we have an automated test suite, but the problem is that it takes so long to run that they've removed it from their pipeline. And in addition to that, because it isn't getting run all the time, it's not up to date. So they have all these tickets in their backlog to update the test suite that they're not running. So that's not very good. My name's Amy Fairbrother, and I'm a senior front-end engineer on the XT Boston team. Despite what People Portal says, I started my career in 2013 at Sapient. During that time at Sapient, I worked here about 3.5 years at that moment. Back then, we didn't really write any tests, and that seemed okay. Solving these problems that might have been our own fault seemed like the cost of doing business. Writing tests on the front end was a little bit tautological to me. After that, I landed product side. And I worked at a company that was in the travel and hospitality industry. We didn't really write any tests there either, but it was also the wild, wild west. We spent a lot of time solving problems that we didn't necessarily need to if we had written some tests in the first place. After that, I landed at a financial service company where all of these things really fell into place for me. We did a lot of test-driven development. And at first, I wasn't really sold on it, but then I realized the benefits of this. We released an investment platform over the course of a year where we completed 1,000 user stories, and only 3 of them resulted in defects that ever got to the client. And the interesting thing is that every single story that we wrote had at least one test applied to it. And when it was time to leave that company, I realized what I wanted to do. I wanted to come back to agency life because I really liked the benefits that it afforded me. But I also wanted to bring those learnings to the agency world, where I could maybe help some people that are doing really cool work save themselves from a lot of frustration. So let's get started. I want to talk about some things that I learned that we should apply here. And I've had some pretty interesting degrees of success and some failures. trying to apply those things to the work that we do here. So before we really get started, I want to talk about the anatomy of a pipeline of our automated test suite. There are 4 basic parts, and all of them are pretty important. The first part are unit tests. Unit tests are the smallest pieces, are tests that ensure that the smallest pieces of your code base work exactly as specified in complete isolation. These tests run pretty fast, and they're not really given to a lot of failure because they're testing such a small piece of the code. Tools like Jest or React Testing Library come to mind here. You also might have heard words like Mocha or Chai in terms of assertion libraries that you can use when you're talking about unit tests. The next part are integration and end-to-end tests. Integration tests might test that a few components work together, or some components and a third-party service work together. End-to-end tests, on the other hand, are related, but they sort of cast a wider net. End-to-end tests load up the entire environment where your app runs, whether it's a browser or your actual phone with an app on it. These tests take a little bit longer to run because there's a much bigger system that you have to set up in order to run them. But they allow you to run through your tests as a user would run through your website. And tools like Puppeteer or Cypress come to mind when we talk about integration or end-to-end tests. The next part are pipelines. Pipelines are the tools that take away the kind of grunt tasks that you might do as a developer. These are the things that will listen to your Git commits to see when new code has been processed. And it might run your tests, but it also will probably run your build process and push your code up to your browser or to your server. Tools like Azure DevOps or Jenkins are tools that might come to mind here. A lot of projects at Sapient use them. The next piece are reports. Reports are super important because they're generated based on what is run in your pipeline. They include information like coverage percentage, how often your code fails, what percentage of your code is tested, and how long it takes to run them. This information is very important because it helps you communicate with members outside of your team and also with engineers on your team. For the purposes of this talk, though, I'm going to focus on the first 2. And the reason that I'm going to focus on unit tests and integration and end-to-end tests is that in talking to engineers that I work with, these two seem to be the things that we really get hung up on. We get hung up on how many of each type should we have, or am I doing this right? So a big question that we asked ourselves is, how many unit tests versus integration tests should we have? You might have seen this pyramid. The pyramid sort of helps us dictate how we might compose our test suite. The bottom part are unit tests, where we might have a lot of them because they run pretty quickly. And we want that because we don't want our test suite to take too long to run. On top of that, we have service tests, which may also refer to integration tests. You'll have a smaller amount of them, but not as few as UI tests that we have at the top because they take the longest to run and we don't want to spend a lot of time running them. You also might have heard this quote from a very smart guy. Write tests, very few, mostly integration. Well, no offense to Can't See Dodds because React Testing Library is really cool, but I don't agree at all. What if I told you there's no formula for the perfect test suite? What if I told you there's no ideal test suite? What we should be doing is choosing the appropriate testing approach for any feature or bit of code that we're writing, whether that means all unit tests or all browser tests, or more commonly, some combination of both of those things. The reason for that is that what really matters when we're testing is that testability is a function of controllability and observability. So what does that mean? Controllability is the ability to put inputs into my code and be able to expect the outputs of them without too many side effects. This is where things like functional programming or writing pure functions becomes really important for us because we want to be able to put in a bunch of inputs, but we also need to be able to expect what comes out the other side. Observability, on the other hand, is the ability to be able to see the result of these inputs and understand them in a useful way. So, to give an example, let's talk about two different features that you might have on your project. The first one is a form input. As a user, I want my form input field to accept validation rules so that I can be informed when I'm not providing the correct information for a field. If I were to build this component, I would probably build the component, but then when I write tests for it, I would probably use a lot of unit tests because this is a very small piece of our code, and probably having a lot of tests here is more important than having a journey test that tests one specific input field. The other feature that you might have is a registration form. It's a multi-step registration form in this example, and I don't know about you, but I've built that a bunch of times in my career. So as a user, I want to be blocked from advancing to the next registration step if the information I entered isn't valid, so that my registration can be completed accurately. So if I were to build this feature and test it, I'd probably use a lot of journey tests. I might have a couple of unit tests or an integration test to ensure that maybe my reducer works properly. But I really have a lot of journey tests because I want to know that this works in an entire flow. So firing up my whole browser is probably a good choice here. But the point is that both of these features are different, and thus the testing approaches for them would be different. To give an example from a project I actually worked on, this is a test coverage report. You've probably seen this before if you've written any tests. Basically what this does is it runs all of my tests, and it looks at all the components that I have in my code, and it gives a little report about how well something has been tested, at least from the purview of this tool. The green components are components that have allegedly been tested well. The yellow ones are a little bit less well tested, and the red ones are very poorly tested. I think this testing library uses 80% as its test coverage goal. So when we look at this really quickly, we also see these two components that look like they're not very well tested. And actually, it turns out in this project, these two components are very important to the function of the entire project. But it turns out, due to constraints of the project, we weren't necessarily able to write them in a way that made them easily unit testable. So in order to satisfy some testing requirements and make sure that we don't actually break something down the road someday, we used a combination of approaches. You can see that with the order review component, we did unit test what we were able to unit test, but not so much on the measurable component. And so in order to fill these gaps, we had a bunch of end-to-end tests. But if we were having this traditional conversation, we would only see this coverage report and seem like we didn't really test all of our components maybe the way we should have. So armed with this new point of view that we're going to use whatever testing approach works best for any component so that we can understand that we do not necessarily put out any code we don't intend to, let's talk about some common pitfalls and how to change the conversation around that. The first one is, my project doesn't measure the efficacy of my test suite. We only measure the coverage percentage. The first thing I want to say to that is, coverage percentage is a vanity metric. But let's break that down because that's probably pretty harsh language compared to what we might have normally heard. So let's talk about how we actually calculate a coverage percentage. All it does is it takes the number of lines of code executed by any test that I have and divides it by the number of possible lines it could have executed, and then it multiplies by 100 to give us a handy little percentage. So this is blindly calculating this percentage, but what it doesn't do is make any distinctions about the quality of my tests. We don't talk about whether or not all of my tests look like this. And if you write any tests in React, you've probably written this test. Basically, all this test does is it loads up a component that we have, it puts data into it, and then it asserts that we get something out, something that looks like a React component maybe. So this doesn't really tell us much. All it does is tell us that React can do what React is supposed to do. And that's a good thing, but not really useful for our purposes. And interestingly enough, I was on a project where a test like this actually increased the coverage of a component to 70%, but it completely ignored any of the salient logic within this component. And that logic would have been easily tested because it happened to be a pure function. So in the end, actually, coverage percentage is trying to be a proxy for testing behavior. But since there's no real way to measure that we've actually tested all of the behavior in a component, we use this handy coverage percentage. And the reason we use it is because it's easy to get. It's easy to get because every single testing library has a way to give you a coverage percentage. So what should we do instead if that's not a really great measure of the quality of our tests and ensuring that we actually understand what our code is doing? What we should do is understand that coverage percentage should be a number that's agreed on by the team. We should have this discussion together to see what a baseline we need to maybe get a feel that we've written the right amount of tests. Coverage percentage is useful if we say that this is a baseline for when to stop. Engineers have a pretty hard time knowing when we've done enough work. This will give us a nice baseline, but it won't necessarily inform that we've done all the work we need to do. The next thing that we should do is have a conversation about why our coverage percentage on our code base is set the way it is. Sometimes it comes down from a client, but sometimes we make that decision on our own. And we should really make sure that we've picked a number that makes sense for us. And we can talk about why that is in a minute. But things we can do instead of talking about code coverage percentage is, let's talk about the speed from feature development to deployment. So how long does it take to get from actually writing the code to writing tests for the code and then deploying the code to a user? Also, let's talk about the reduction of the amount of time spent in regression testing. I'm currently on a project where that's a 2-week manual process. If we had a robust test suite, we could certainly make that take a lot less time and use everyone's time in a more efficient way. We should also talk about the reduction of number of defects in production. So fewer defects making it to the user, I think, is a win for everyone. The next problem is my project doesn't have enough tests, or conversely, my project has too many tests. So the number of tests on your project matters, but only as it applies to developer pain. So what do I mean by that? Well, let's talk about 2 different ways this could go. First of all, if your project has so many tests that changing a single line of code means that I have to change the majority of my tests, your test suite is not effective. And the reason it's not effective is because you spend too much time updating tests. Now, on the other hand, if I can add an entirely new feature to a code base and I don't have to change any tests, your test suite is not effective. And the reason it's not effective is because you don't have enough tests to understand whether or not the code that you wrote for your new feature has unintended consequences with what you already have written. So let's look at this chart. Basically what it says is that as code coverage percentage increases, the amount of effort it takes to maintain also increases. Ideally, we want to make sure that we're on the left side of this dotted line in the darker pink section. And the reason for that is the Pareto principle. The Pareto principle states that 80% of outcomes are the result of 20% of causes. And from a coding perspective, what that means is the majority of software faults are going to be found by the minority of your tests. So what we need to do is set a code coverage percentage that doesn't drive us crazy as engineers. So, and the interesting thing is that a lot of teams sort of report diminishing returns as they reach a code coverage percentage above 80%. The last problem I want to address is our test fails often for no reason, causing us to rerun the pipeline, or our tests take so long to run that we've disconnected them from the pipeline entirely. So really quickly, I want to talk about why your tests might fail for no reason. If you're writing tests that are mostly user journeys, it turns out that user journey tests are given to failure for no reason. And the reason for that is that we might be setting up this large system that has to work together. And the tools that we use, like Selenium or Nightwatch or Appium even, they're a little bit given to being finicky. And we call this test flake. if you do some reading about this. And what that means is when we fire up this process, when we run the test, sometimes the test might fail. And then if we rerun the test without changing any code, the test might pass. And that's not very good, right? Because if we have this test suite that's running, we lose all that time when we rerun the test suite. We lose all that time, and now we need to rerun it again and maybe lose that time again, or it might pass, and now we don't have a lot of confidence as to why it passed. And related to this is if your tests take so long to run that you disconnect them from the pipeline, you lose any of that efficacy within your test suite because you're not running it often. And if your test suite takes a long time to run and it's flaky, you can see why this is a problem because it increases the length of the feedback loop. So what can we do to address that? Because what we want to do in the end is really ensure the longevity of our test suite. And that means that it should change over time to really suit the purposes of the team and what features we're building at any time. So the first thing we can do is sit down as engineers and really have a conversation about the state of our code base. I know that a lot of projects have developer retrospectives, but it's not really devoted to just talking about the actual quality of the code that we're writing or the health of the code that we've written. So what we can do is sit down and actually measure certain things and keep track of them over time. So one thing I would measure is how flaky is your test suite on a scale from 1 to 10? How does the team feel about it? Or how long does your test suite take to run? Do you even know how long it takes to run? These are good questions that we should ask. And as a team, you should have these like really hard discussions so then you can create tickets and work on them in the future. Another thing we can do is if we have a test that's especially given to failure, we can talk about if we have other options. The good thing about being an engineer is that we know that there are many different ways to solve the same problem. So maybe there's a way we can learn the same thing from a test, but do it in a different way that maybe runs faster and isn't given to failing for no reason. The next one is a kind of maybe an unpopular opinion, but it's if we have a test that passes literally every time and would require a mysterious planetary alignment to fail, you should delete it. What are we learning from a test that really passes all the time? And if it passes all the time, it makes me wonder whether or not we're testing our own code, or are we testing a package that we're using instead? And if we're testing packages that we think we need to test, but we didn't write them, we should probably use more trustworthy packages. And we should really sit down and have conversations as teams that we're not having. And this would help us really move forward to make sure that our test suite tests what we want it to, when we want it to, and how we want it to. So in conclusion, writing an effective test suite is like getting a custom tailored suit or dress. You don't have to weave the fabric yourself, but you do have to take your own measurements to make sure that you achieve the look that you want. Thank you.